welcome to the video about inverse trig function. So on this first one, I'm trying to figure out the answer to the inverse sine of 1/2, and we could also call that arc sine. Arc sine. All right, so this means, by the definition of what it means to be an inverse, this means that the sine of theta is equal to 1/2, and then we can recall that terminal point at √3 over 2 and 1/2. Okay, the sine is talking about the y value, and the angle there is pi over 6, which is the same thing as 30 degrees. Another way of looking at this is if we have this equation, arc sine of 1/2 is equal to theta, you could take the sine of both sides of the equation. So taking sine of both sides, and then the canceling properties mean that the left-hand side simplifies down to 1/2 is equal to sine theta. So both ways of looking at that get you to the same place where you can solve for your angle there. All right, let's see, cosine, arc cosine of √2 over 2. So this would mean that the cosine of some angle has the value of √2 over 2, and that is at the angle pi over 4, because that terminal point √2 over 2, and for both the x and the y. And on this one, we would have the tangent of some angle theta is equal to square root of 3, and that corresponds to 60 degrees, or pi over 3. That is our 60-degree angle, where we have, let's see, the x is 1/2, the y is √3 over 2. And then y over 3, or sorry, y over x for tangent simplifies down to √3. Okay, so then we have what our angle is equal to. And we can also do this on all of these were on the unit circle, so we could get the exact values, but you can also use your calculator and work these out. So you can just type this in and you'll get approximately 53.1 if you're in degree mode, and if you're in radian mode, that would be about 0.9 radians. Usually for the applications, we just typically use degrees a little bit more. Okay, so on this one, we would have that's about 72.5 degrees, and that's equivalent to about 1.3 radians. All right, and then tangent, this is about 76 degrees and about 1.3 radians. All right, so now let's put together what we know about our inverse trig functions and what we know about right triangles. Okay, so let's see, I'm supposed to find my angle, and this is my angle right here. I have a right triangle, so I have an adjacent side and I have a hypotenuse side, and I always have to write these down. Okay, so let's see, which trig function has an adjacent and a hypotenuse? That is the cosine of some angle, and the cosine is the adjacent over the hypotenuse. So we have cosine of our angle is going to be equal to 109 divided by 134. And then this idea of we can take the arc cosine. You can do anything you want to an equation as long as you do the same thing to both sides. Canceling properties mean that our left-hand side simplifies down to just x degree, that's our angle. And then we have this arc cosine or inverse cosine of 109 over 134, and just pull out your calculator. And let's get a degree approximation on that, which is about 35.6 degrees. Okay, moving on. Here's my right triangle. This angle is opening up, so across from my angle is my opposite, and touching my angle is the adjacent, and then this is my hypotenuse, which I don't even need in this problem. So I have an opposite and I have an adjacent, so looks like I need to use tangent. Tangent of some angle is equal to opposite over adjacent, and then you just plug your numbers in for those side lengths. So 6.37 divided by 15.3, and then we'll take the inverse tangent of both sides. 6.37, I'm going to just scoot that up a little bit, over 15.3. So we have that our angle would be the inverse tangent of this, and just pull out your calculator, and we get our angle simplifies down to approximately 22.6 degrees. Now sometimes there's more than one angle that can satisfy an equation. So here we're looking for any and all angles between 0, starting at 0 and going to 360 that would make this equation true. Cosine of some angle is a positive 0.4. I am really looking at that positive, and I am seeing cosine. Remember, that corresponds to the x values on the terminal points, and here in quadrant 1 and quadrant 4 we have positive x values. Okay, so that's a big clue right there that this is positive. Okay, next, let's see. The other thing is we know we could take inverse cosine of both sides of 0.4, and so that would simplify on the left-hand side to theta is equal to the arc cosine of 0.4, and that simplifies, using your calculator, to about 66.4 degrees. Okay, so I found one. Here it is, 66.4 degrees. But there's also another angle, if I went all the way around here, that would have the same reference angle. Okay, so the other one, I'll do this in green. Okay, so the other angle that would be in quadrant 4, that would be almost all the way to 360, but not quite. So that is approximately 293.6 degrees. Okay, good. So we've got both of those. Now in this next one, I am going to pretend like that's not in there because it's not always in there in your homework, but we can use logic. So let's say that it just said find the exact value of cosine of arcsine of 3/4. All right, so I have a right triangle, and let's just kind of go in here and look at just that part right in there. Okay, so arcsine, here I'm going to actually write it over here. Arcsine of 3/4. Okay, so that, what is coming out, it's saying what is the angle that when you take the sine of it gives you an answer of 3/4. Well, we can figure this out. Let's see, I'm going to let this be my angle, and then just remembering sine is opposite over hypotenuse. So that means that I have my opposite is 3, my hypotenuse is 4. Okay, so here, what comes out when you take the arcsine is some angle. So what's happening is this is going to just simplify down to saying what's the cosine of our angle. Well, cosine of an angle is the adjacent over the hypotenuse. I'm close. I know what the hypotenuse is. That's 4. I don't know what my adjacent is. Let's see, that would be over here, adjacent. I'll just let that be x. So I'm going to use the Pythagorean theorem. I've got x squared plus 3 squared equals 4 squared. So x squared equals 16 minus 9. And so x could either be positive or negative square root of 7. And the only possible answer here is a positive square root of 7, just because of how arcsine is defined. That function is only defined in quadrants 1 and 4, and quadrant 1 is the only one where the y values are positive. So it has to be in quadrant 1. Quadrant 4 doesn't work because it wouldn't have a positive y. How do I know y is positive? Right here. Okay, because inside here that's positive. We could have also gotten a positive by taking a negative divided by a negative, but this is the hypotenuse. Hypotenuse is always a positive number, all right? Okay, so that just means we're in quadrant 1, and so we've got our final answer as a positive square root of 7 over 4. Okay, moving on. We have a 30-foot ladder leaning up against a building. Okay, so I have my ladder leaning up against my office here at Windward Community College. It's a 30-foot ladder, and it's 11 feet from the base of the building. And we want to know the angle formed by the ladder and the building, so that is theta. Okay, I always like to just actually put myself in here. Inside my angle here, my angle is opening up towards the opposite side. So 11 is opposite, and 30 is my hypotenuse. So we're going to use sine because that is opposite over hypotenuse. And so we would get sine theta. Just plug those numbers, those lengths in. We would have opposite, oops, that's 11 over 30. So theta is the arcsine of 11 over 30. And just go ahead and pull out your calculator, and we would get that is approximately 21.5. And then we'll just explain what that means in a sentence. So the angle formed between the ladder and the building is approximately 21.5 degrees. Okay, few little things just to remember from geometry. With parallel lines that have been cut with a transverse, the angles that are created that are opposite each other, those are equal. And then the alternating interior, those are also equal. And then the alternating exterior, so let's see, that would be like this one and this one. Okay, so let's go ahead and use that for our next problem. So we've got a worker on the top of a power line, and he's working on the signal. Okay, so it's an 18 feet. It's pretty high up there. He's clinging, hanging on for dear life, happy, doing his job. Right there he is up on the top of the world. Now, down below, he sees a police officer who's 7 feet from the base of his power line. And what we want to know is, we need to know this angle of depression right in there. Okay, now based on alternating interior angles, we have that the angle created over here, that is also theta. Okay, now using our trig definitions, I have an adjacent side and I have an opposite side. So I'm going to use tangent. Tangent of theta is opposite over adjacent. So tangent of theta is equal to 18 over 17. And that gives us the arctan is 18 over 17. So theta is approximately 69 degrees. There we go.